Okay, so I've been waiting for one of these for a while. This one's perfect because it has multiple failures, but what we're doing here is a AC system diag. How do we figure out what's wrong with our AC, right? Okay, so the first thing you want to do is get in the car, start it up, get it warm. The first thing out of any diagnostic testing is you want to make sure that your mix and your mode and your selectors work at all. So first thing you do, get it in, get it warm. Turn it to hot, put it on face low speed. Okay, now you're going to want to feel the heat, right? You want it to be warm on your hand. Now if it's not warm, that's a whole different diagnostic. We're only talking about AC right now. So then what you want to do is turn it all the way to cold and then turn your AC. Now what you're listening for is a change. You're hearing the mix motor or the vacuum motor or the electric motor, or you're looking for something to change it. Listen, let's see if we can hear this again. You can kind of hear it. Okay, so now we know that our hot and cold mix is working. So the next thing we do is we come out here while the engine's running with the AC on to see if the compressor is running. Now in this particular instance, I've already been through this and I already know what the problems are, but I just want to make a procedure. So if your compressor is not running, then you have to do a couple different tests. So this particular process applies to vehicles that have an AC relay. Now some vehicles, like some Toyotas, and Mitsubishis, they have a relay that's built into the fuse box, which is stupid, and that this testing does not apply here. So the first thing we do is we pop our top here and we find out where our AC relay is. So right here, where this connector pin is connected, is our AC relay location. So first thing we do is we take our meter, put it on ground, and we stick it in these holes. Now there should be 4 holes. On the relay there's a power supply and a load. There's going to be a power supply and a switch. Now 98% of cars use the ground to switch. Some of them use the power. So what we're doing here is we got our tester in the first spot and we see we got 12 volts, okay? That's our coil feed. Second, we're going to move over to our line that actually goes to the compressor coil. So we got nothing, and that's normal. Okay, so next we go to the control side. Okay, nothing there. And this side, okay, we got power there. So we know that the control side and the load side have power. Okay, so the next thing we want to do here is we'll stick our probe into our coil supply, and what we'll do is switch to continuity. We'll unplug our compressor connector. Now some of these aren't going to be right on top. Some of these are going to be kind of a bitch to get to, and that's just part of the deal. So come over here and we measure our continuity between the relay and the connector. Okay, so 0.7 of an ohm. That's probably just because I got a poor connection here, but not really concerned about that. Next thing we're going to do is we're going to put our negative on. We're going to go to continuity and we're going to stick it in the other hole to verify that we have continuity to ground. Okay, 15's a bit high, but okay, so just for the sake of ease, I had this preset up. So next thing we're going to do is, now I usually use a power probe for this, but I'm doing it this way to prove that it's easy to do. So it doesn't matter how you have this hooked up. These are just alligator clip jumper leads. So what I do is go from negative to one side of the connector, and then I take my other side and touch it to the battery. Oh, pay attention. Okay, so you hear how it's sparking. All the ozone. Now the clutch is not moving. So kind of hear it trying. It's kind of moving a little bit there, but it's not. Okay, so that tells us that the first problem we have is that this clutch is burnt out. Either the coil's shorted or something in this area is bad. Something with the coil is bad. So that's our first problem. Now, usually what we would do at this point is, if the compressor does turn on, we would start it and kind of feel on these lines here. If you can get to them now, like I said, this is a Dakota. That's everything's easy here. So your output side is going to be smaller, and there's going to be a high pressure switch, and the input side is going to be smaller. This is the suction side, and it always comes off of the accumulator. The accumulator is where the cycling switch is. This is what actually controls the cycling, the relay. Okay, so one thing I forgot to mention here is when you're doing the continuity test between the relay and the connector, if there's no continuity, the next thing you do is go from the relay to the cycling switch. Now, if there's continuity there, then you're good. If there's not, then you have to probe through here and verify your wiring between the two sections. But that's not what we're doing here. So the next step, what we're going to do here, since I already know how this is going, is there's no heat here at all. Nothing, since the compressor didn't kick on. Nothing happened. Usually what happens with these is the ports leak here and over there. It leaks out the refrigerant. Now the oil that's in this is dissolved in the refrigerant. So when the refrigerant runs out, the compressor does not get fresh oil and the compressor burns out. So the next step here would be to recover the refrigerant and find out how much is in there. But since I've already went through this, this is, make sure you're wearing safety glasses, but if you touch on this rear valve, you should hear a psst, or there should be some sort of resistance on there. If you push on it and it stays, you know there's something in there, but if you touch it, nothing happens, you know you have a leak. Now inside there, it's just a Schrader valve, just like a tire, right? And then on this side, this one has the GM style with the ball. These are dumb. So rule of thumb here is, anytime you have to evacuate the system to repair or recharge or put a vacuum on it, always replace these charge ports, because it's very common overly looked. You say, okay, there's no leaks on that condenser, I don't see any leaks on any of these fittings anywhere, and then you put the machine on, suck it down, and oh, well, the leak test passed. Well, yeah, it's because the leak is here and you have the connector on it. You'll never know. So at this point, we know that the compressor clutch is bad. We know there's no refrigerant in it. So if you are doing this in your backyard, what you're going to want to do is replace the compressor. And also, the right way to do it would be to open up the condenser outlet and spray a couple cans of flush through it, high pressure flush, and then blow it out with compressed air. Because typically what happens is the pieces of metal come from here through this hose down through the condenser, and they get stuck inside here. Then they come up and then they go through the expansion valve, which could either be here or somewhere higher in the system. So when you're looking for the expansion valve, you see, well, maybe not, but down there there's a connector. Usually they're in a straight section like that. See how that's got insulation on it? I'm betting that the expansion valve orifice tube is in there. So the right way to do this is, after you flush it, is to replace that valve, because there's a little screen inside there. Well, I thought I had one to show, but I don't. Basically, it's like a cone about that long, It's a cone, and it has a screen in it. Oh, there it is. Boom, found it. Boop. So that's what your tube looks like. It sits in the line like this. All the debris and shit's gonna build up and build up and build up and build up, and eventually gonna lead to high side pressures, and it'll eventually clog it. But that's what the valve is. It's just a little chunk of brass. So the other thing to mention is that if you're doing this on your own, do not use those cans of Magic AC in a bottle from AutoZone that contains sealer. What the sealer does is when it hits air, it turns into rock, it hardens up, and then it seals it. So the problem with that is the next time that you actually have it replaced or fixed or whatever, as soon as you introduce air into it, all that sealer is going to get rock hard inside the system, and it'll eventually start breaking shit because it turns into fucking rock. It's like epoxy. As soon as it hits air, it hardens up. Another problem with that is if you don't have a vacuum pump and you're just, like this one, there's nothing in it. So if you know that all the refrigerants come out, the air can get in. And with the heat cycles getting hot and cold, you know that the air has gotten in there. So when you put that shit on there and you pull the trigger, it puts the sealer in there while there's air in there, and it already starts hardening up anyway. So you might get a little bit of success with it, but eventually it's going to clog up the expansion valve and the compressor and the condenser, and it's just a waste of time. Buy the shit that has no sealer in it, or just take it to somebody that has a machine and let them do it right. The other thing is that when you're repairing or replacing components like the compressor or the condenser or the accumulator or the evaporator, you have to add oil to it. You can't just put it in there and call it good. They call it balancing the oil. So when you take your old compressor out, you drain it into a cup. You take your new compressor, they always come with oil, drain it into a cup, and kind of decipher what the difference in oil is, and then add oil in proportion to how much came out. So if you drain it and maybe an ounce comes out, add an ounce, and then add maybe another ounce or two, just because you know that some of it's leaked out. It's always better to have a little bit more than not enough, because you'll end up burning it up. But on the flip side, if you have too much, it kind of makes the AC performance suck anyway. So with all that being said, we know that we have power here. We know that we have continuity to the compressor through our wiring, and we know that the compressor coil is bad, and we know there's no refrigerant in it. So at this point, what we're going to do is, well, since this is not a backyard, I'm working at a shop here, so what I'm gonna do is give the customer the option to replace the compressor and hope for the best, or replace the compressor, the valve, and the accumulator. Now, if you buy a kit from like Napa or something and you're a shop and you want it to get warranted, if you want to have a warranty on your parts, you have to replace them all. Now, if you go down to your local parts house there and you order a compressor and it says lifetime warranty, make sure you ask about the asterisk in the small print, because usually it means lifetime warranty if you replace all the other components. So what'll happen is you'll see, look, the relays clicking. So you'll get your compressor, put it in, all the shit will be in the system, and the new compressor will grenade after a couple hours. You'll take it back and say, this is a piece of shit. And they'll say, oh, well, did you replace all the other stuff? Well, no. I'm sorry, it's not warranty. And you get fucking stuck with it. So this is just kind of like level one. I'll start uploading more videos of this as I see them, because it's now July, and we're starting to see AC jobs come in.